So this is going to be part 2 of section 2.4. And it's not particularly harder. The video was getting a little bit long and the problems changed a little bit. So I decided to just make a second part. I'm going to do a few examples before we get into the rest of the homework problems. First example is 2 cities are 1,000 miles apart. How many kilometers are they apart? This is really just asking me to convert from miles to kilometers because it tells me the distance in miles and it wants to know the distance in kilometers. And how do I convert from miles to kilometers? Well, hopefully I can do it with one fraction. And I see 1 mile is 1.6 kilometers. So to get my answer, I'm going to multiply by a fraction. In the numerator, it's going to have what I want to end up with. I'm converting from miles to kilometers. It's going to have kilometers that I want to end up with in the numerator, miles that I want to get rid of in the denominator, and I'm going to use 1 mile and 1.6 kilometers. And units are going to cancel, and I'm just going to take 1,000 and multiply it by 1.6, and I think you're just going to get 1,600 kilometers. So the answer to this example, 2 cities are 1,000 miles apart. How many kilometers are they apart? I'll say it's 1,600 kilometers that they're apart. Comes another more complicated example that kind of takes some of the volume that we learned in the last section and blends it with unit analysis or dimensional analysis. It gives me a rectangular prism and asks me to find the volume in cubic feet. I'm going to use the length times width times height formula. I'm going to call this the length and this the width, because usually the length and width are on the rectangle that has 2 sides labeled, and then the other side's the height. But really I just need to multiply the 3 sides together. So I just took the 3 numbers, 20, 5, and 8, and multiplied them together. The volume for this rectangular prism or this box is 800 cubic feet. The thing that is more challenging is to handle part B. So if I filled this up with liquid, how many gallons of liquid would it hold? And what I have is I have the volume is 800 cubic feet, and I want to change that into gallons. This is what this is asking me to do. It's asking me to take the 800 cubic feet and change it into gallons. And to do that, I need to use this relation that we haven't got to yet. That 7.48 gallons is 1 cubic feet. So to change from my 800 cubic feet that I came up with for the volume of that rectangular prism or that box, I'm going to multiply by a fraction. In the numerator, it's going to have the units I want to end up with, which is gallons. In the denominator, it's going to have the units that I want to get rid of, which is cubic feet. Next to the gallons, I'm going to put 7.48, and next to the cubic feet, I'm going to put 1. And when I do this on my calculator, I just have to multiply the 800 times the 7.48 to get the numerical part of 5984. The units are going to work themselves out when I cancel out the cubic feet. So how many gallons will this hold? It's going to hold 5,984 gallons. One more example before we jump into the word problems. So my car, I think, has an 11-gallon gas tank. So a car has an empty 11-gallon gas tank. Assume gas is selling for $11 per gallon. How much will it cost to fill up? I didn't think unit analysis was necessary to know if I'm spending $3 per gallon and I'm filling up with 11 gallons just to multiply the gallons times the cost per gallon to get the cost. And so I just did that. I said, that's hardly worth unit analysis. Take the 11 gallons times the $3 per gallon, and it's going to give me $33. Technically, this is this. I'm doing 11 gallons times $3 is equal to 1 gallon. That's really what the $3 per gallon turns into as a fraction. I'm going to cancel out the gallons. I'm going to be left with dollars, and 11 times 3 is 33. But like I said, that's not worth unit analysis. So part A, for this car to fill up an empty 11-gallon tank, if you put exactly 11 gallons in, it's going to cost $33. Assume gas is selling for $1.50 per liter. how much will it cost to fill up the gas tank. This is a more complicated problem. I think probably the easiest way to do this is to figure out how many liters the tank is going to hold. So the first thing I'm going to do is I'm going to first find out how many liters this tank will hold. And how do I do that? Well, I know I'm starting with 11 gallons, and I want to change to liters. Best case scenario is I could find a fraction that has liters, or an equivalence between gallons and liters. I hope I have that. I don't know that I do, but I actually do. I have that 1 gallon is 3.8 liters. So I'm going to find out how many liters this tank holds, and then I'll figure out the cost. So I'm going to use the fact that 3.8 liters is equal to 1 gallon, and I'm going to find out for this gas tank that has 11 gallons of gas when it's empty, how many liters it has. And this tank has 41.8 liters. So to fill up this tank, I have to use 41.8 liters. If gas is selling at $1.50 per liter, I could just multiply to get that, or I could do something fancy. I can say 41.8 liters times $1.50 for 1 liter. I could cancel out the liters, be left with the dollars, but ultimately, really, I just need to take the number of liters times $1.50 per liter, and I'm going to get the cost is $62.70 to fill up this tank in if it's $1.50 per liter. $1.50 per liter is like $6 per gallon, because basically there's 4 liters in a gallon. That's why it costs so much. And if you go to Europe where they sell gas in liters, it's really expensive there. You can tell this is a little bit old because gas really isn't $3 right now, but it'll probably at some point be more than $3 again. All right, so now we're ready to do some homework. The end of our homework for this section. 31 and 32 are essentially the same problem. For 31, you have to find out the distance between Cincinnati and Columbus is about 110 miles. What's the distance in kilometers? Minus the distance between Phoenix and Flagstaff is about 140 miles. What's the distance in kilometers? Both of us, to get our answers, were given a unit in miles, and we're asked to change from miles to kilometers. The best way to do that, if it's possible, is to find one equivalence between miles and kilometers, and we have that. We know that 1 mile is 1.6 kilometers. To convert, to figure out how many kilometers these two cities are apart, I'm going to multiply by that fraction that has miles in the denominator and kilometers in the numerator. The answer to my question is going to be 224 kilometers apart. For your 31, I think you're going to get 176 kilometers apart. Oh, this is about the same problem, but backwards. Two cities, let me just do 33 with you and not do 34. So two cities are 400 kilometers apart. How many miles are they apart? I just need to convert from kilometers to miles. I'm going to use the same relationship, but just upside down. I want to get rid of kilometers and wind up with miles. So the fraction that has the 1 mile equal to 1.6 kilometers is going to have the 1 mile in the numerator because I'm ending up with miles, and the 1.6 kilometers in the denominator because I'm getting rid of those. And now I'm going to go 400 divided by 1.6, and I'm going to get 250 for the number, and my units is miles. So the answer to problem 33, these two cities are 250 miles apart. Both of our problems 35 and 36 are asking us essentially to do the same thing. My problem 36, a bathtub has 50 gallons of water. How many cubic feet of water does it hold? And yours is similar. For each one of our problems, we need to change from gallons into cubic feet. The best way to do that is to find one relationship between gallons and cubic feet. If you can find the relationship between gallons and cubic feet, you can do this with one fraction, and we have that 7.48 gallons is 1 cubic feet. So I'm going to multiply by the 1 cubic feet is 7.48 gallons, and that will help me get my answer because the gallons will cancel. The units are what I need to have, it's cubic feet. And then 50 divided by 7.48 is going to give me 6.6, it says round to 2 decimals. My answer for problem 36 is going to be 6.68 cubic feet. So this bathtub will hold 6.68 cubic feet of water. And problem 35, your swimming pool should have 1,671.12 cubic feet rounded to 2 decimals. All right, so I'm going to leave myself a lot of room here. So our problems are kind of, sister problems. They're the same questions with different numbers. So my 38, a pool is 25 by 18 by 5. What's its volume in cubic feet? To find the volume of a pool that's a rectangular prism, you just multiply the length times the width times the height, or the depth. I'm going to do 25 feet times 18 feet times 5 feet. I'm not going to attempt to draw this pool. And the volume is going to be 25 times 18 times 5. The answer to part A for number 38, the volume of my pool is 2,250 cubic feet. For part B, how many gallons of water will it hold? Well, I need to convert the 2,250 cubic feet that I computed in part A into gallons, and I'm going to do that by multiplying by a fraction that has gallons in the numerator and cubic feet in the denominator, and I'm going to use that same 7.48 gallons as 1 cubic feet. I'm going to cancel out the cubic feet. When I go to write my answer to part B, my unit that's left is gallons. I guess I could abbreviate it, but I'm just going to write it out. And numerically, I just multiply the 2250 times the 7.48, and the number I'm going to get, this pool holds 16,830 gallons. When you go to do your problem 37, there's a part A, which is the volume of the pool, which is going to be 1,200 cubic feet. And there's going to be a part B, how much water can it hold? It's 8,976 gallons. So for 39 and 40, same sort of questions, but we have different shapes. First is to find the volume. Second is to find out how many gallons it holds. And I don't remember the volume formulas, even though I just shot the video this morning. For your cylinder here, the volume formula you're going to need to do part A is pi r squared h. These formulas will be given to you on the test. And the r is going to be half of 3.2. So the diameter for you is 3.2. Your r is going to be the radius, which is half of that, which is 1.6. Actually, is 1.6 feet. Your height is 1.8 feet. Hopefully that's readable. You can find the volume by using this formula. It doesn't say whether to leave pi in my answer. Well, yes, it does. So leave my answer in terms of pi, so I'm going to leave pi in my answer. Heck, let me just do your 39 with you so I don't have to do 40. So what's the volume of this cylinder? So for part A, the volume is going to be pi, which I'm going to leave alone, times r squared, which is going to be 1.6 squared, times the height, which is 1.8. Let me not involve the pi and do 1.6 squared times 1.8. I got lazy and didn't do parentheses. I'm going to get the volume is 4.608 is the number. The units are in feet. Hopefully those feet are actually readable. So the volume is going to be 4.608 cubic feet. It didn't say round to 2 decimals, and I forgot this pi. So that would be a minus something because that pi didn't go away. I didn't change it to 3.14, but I need it. So the answer to part A of 39, the volume is 4.608 pi cubic feet. When I go to do part B, how many gallons of water can it hold, then I'm just going to use that same fraction. So I'm going to take the 4.608 pi cubic feet I'm going to multiply by a fraction that has gallons in the numerator and it has cubic feet in the denominator. Sorry, my phone is ringing and I don't know how to just ignore the call, so it's just going to ring till it goes to voicemail. And that unit is 7.48 gallons as 1 cubic feet. And I'm going to leave the pi, and I'm going to go 4.608 times 7.48. And the number I get is this horrible number. Hopefully it says rounded 2 decimals somewhere, but it doesn't. So I get 34.46784 pi gallons. That's a silly answer, but that's exactly, well, it is the answer that I actually wrote when I did this. So for part 39A, I kept all the decimals. 39B, I kept all the decimals. On the test, I'll be more careful. I'll say rounded 2 decimals, and I won't want 6 decimal answers. That just seems silly. I won't do 40. I'm making a vote to skip 41. It's not particularly hard, but it's a disaster for most students. I don't put it on the test. And so let's just vote to skip this. If you want to work through it, pause the video and give it a try. We actually worked with this shape in section 2.3, so you could actually find the volume again and turn the volume into gallons. But I'm voting to skip that, which means I'm going to skip 42 and move on to 43 and 44. And these are deceptively easy because 44 asks me, the speed limit on much of I-17 is 75 miles per hour. What is the speed in kilometers per hour? Because they both have the same per hour part, I only need to change 75 miles into kilometers, and I'm going to keep the per hour part alone. So for problem 44, I just need to change the 75 miles into kilometers, and I'm going to reinsert that per hour part. And the change from miles to kilometers, the best I can hope for is a fraction that has kilometers in the numerator and miles in the denominator, and I have that the 1 mile is 1.6 kilometers. And so if we were in Canada, where the speed limit's in kilometers per hour, you might see instead of 75, you'd see 112.5, and I'm sure they'd round it, kilometers per hour. So what's the speed in kilometers per hour? It's 112.5, and I'm going to say kmph, km for kilometers, and then per hour. So my answer for 44 is going to be 112.5 kilometers per hour. Your 43 should be real similar, and when you go to get an answer for 43, I came up with 50 miles per hour as the that can't be right. What's this? Oh yeah, yours is backwards. So yes, yours is. So your speed is going to be 50 miles per hour. When you went to do yours, you're going to start off with 80 kilometers, and you're going to convert it into miles by putting miles in the numerator, kilometers in the denominator. You're going to have a 1 and a 1.6, and then you're going to get a 50. But it should be miles per hour for the speed. One last problem to do, and it's a little bit sneaky. It's because it doesn't have the number written. It has the number, well, it doesn't have the number, it has a written number, and that's going to mess me up. This first sentence in my problem 46 and in your problem 45 says this, that 1 gram equals 5 carats. And then it said David's new ring contains a precious stone that's 1/8 of a carat. Find the weight of the stone in grams. What I need to do is change 1/8 of a carat into grams. And I'm going to do that by multiplying by a fraction that has grams that I want to end up with in the numerator and carats that I want to get rid of in the denominator. And I snuck that in there, that 1 gram is equal to 5 carats. For my problem, the 8 is also in the denominator. I'm going to just multiply 1/8 times 1/5, and I'm not even going to use my calculator. I'm going to multiply across the numerator and across the denominator. I'm going to cancel out the carats, and the answer to my problem 46, that stone weighs 1/40th of a gram. when you go to do your problem 45, you're going to start with the 5 carats. I'm sorry, you're going to start with the 2 carat ring. And you're going to multiply by 1 gram is 5 carats. And then you'll get an answer, and you could write it as a decimal, 0.4 or 0.40 grams or 2/5. They're both would be fine. If you do the work here and you go 2 divided by 5, you get 0.4, and the fraction is 2 divided by 5, so they both would be equivalently correct. So that's everything we need for section 2.4. Section 2.5 and 2.6 are completely different, and you don't really need any understanding of the beginning of the chapter to do them. So if you're not feeling comfortable with this and you're feeling motivated, you could still kind of go on, before you get a chance to ask me questions.